Okay, now let's now do the final touch-ups on question 9. Okay, so it says sketched below is the graph of f of x is equal to x minus 8x squared plus 5x plus 14. A, B, and C are x-intercept of f respectively. A, B, and C. D and E are the turning points. Okay, fine. These are the things that we already know, guys. You don't need to be scared of. Calculate the coordinate of E. E is what? The turning point. We know at the turning point, the first derivative, it is equal to 0. So it's just easy stuffs. So what is my first derivative? My first derivative is going to be 3x squared. Sorry, 3x squared minus 16x plus 5, it is equal to 0. And then factors of 15 such that when I add them, it gives me this. It's going to be 15 and 1. And then so it's going to be 3x plus 1 and 5, no, and x plus 5. No. Let me see. Both of them should be negative. Okay. So I have 3x squared minus 15x minus x. Okay, sharp. Then I have x, it is equal to 1 divided by 3, or x, it is equal to 5. Something doesn't add up here. Oh, yes, it does add up. So here, the coordinate here, it means x is going to be 1 divided by 3 with whatever y value. But we're interested in this one on E. At E, at E is going to be 5 and the y value. So we're going to say f of 5 is going to be x cubed minus 8x squared plus 5 into 5 plus 14. Is it like this? Negative 8, yes. Okay, let's now quickly confirm on our respective calculators. How much do we get? When I have 5 cubed, no, not squared, 5 cubed, minus 8 times 5 squared, which is 25, plus 25 plus 14. I get 89. So the coordinate of this one, it is 89. Sorry. If I wanted to go the coordinate of D, well, it wouldn't have been that difficult because I just substitute 1/3, okay? For which values of x is f concave down? For something to be concave down, for concave down, the second derivative is less than 0. For concave up, the second derivative is greater than 0. So now let's set our second derivative to be greater than, okay, concave down to be less than 0. What is my second derivative? I already know my first derivative to be equal to 3x squared minus 16x plus 5. So my second derivative is going to be just 6x minus 16. Let me just confirm 6x minus 16 should be less than 0. And then x should be less than 16 divided by 6, 8 divided by 3. Let's see, 8 divided by 3, it is approximately 2.667. So it's somewhere here. 2 point, let me write it as 8 divided by 3. And whatever that respective y value. So this is my point of inflection, okay? Okay. So yeah, and you can see for it to be concave down, it should be less. So can you see this here? Okay. It's fine, guys. What you can do, you can find the second derivative and equate it to 0, find the x, and then look at your graph. Now, 9.3, it says the coordinate of B are 2 and 0. The coordinate of B are 2 and 0. So we have 2 here as the x-intercept. Use your graph to determine the values of x for which f of x multiplied by the second derivative is less than 0. So I need to draw the graph of my first derivative, and the second derivative rather. So I know my second derivative, I know that when I derive my cubic function, it's going to give me a parabola like this, and the point of inflection is going to be the turning point. Point of inflection is going to be the turning point, and when I derive the parabola, it's going to be the straight line, and the turning point is going to be my x-intercept. Okay. gonna be my x-intercept, and then it means now I have something like this. Let me do this. So it means this point of inflection, which is 80 divided by 2, it's gonna be my x-intercept, okay? And then I can I can locate this part and say, okay, let me find if it is equal to 6x minus 16, then x-intercept, I already know it is 8 divided by 3. Y-intercept is going to be negative 16. Okay, so negative 16. So I'm going to have a graph like this somewhere. Okay, how is this positive 39? Guys. Let's go back here. Let's go back here. This can't be 39. Okay, that can't be 39. That can't be 39 at all. Let's just confirm. 39, the value of y should be negative there. So I have 5 cubed, and then minus 8 into 5 squared plus 5 into 5 plus 14, negative 36. Sorry about that, guys. I see. This can't be negative. This can't be at all be negative. Okay, yes. So I've rectified that. Sorry for those who were angry. So we say it's going to be negative 16 somewhere here. I'm going to say negative 16 somewhere here. So I'm going to have a straight line, maybe something like this. That's going to look something more or less like that. Let me, okay. Let's say it's something like, or maybe let me put negative 16 here. Hey, I'll just sketch the graph, just a basic sketch, guys. Okay, and say this is negative 16. Okay, the reason I'm drawing this so that it becomes more visual and it makes sense. So let's continue. This is f prime prime. So now we want y. We want the values of where I multiply the derivative with the second derivative to be less than 0. So it's either this one is positive or this one is negative, so that the product can be negative, or this one is negative, positive. Let's look at the first one. Where is f positive? F is positive on this portion. Okay, and where is the graph negative of the, what is this? Where is my straight line second derivative negative on this portion? So I want where they alternate at the same time. Where they alternate at the same time, it is this portion as well as that portion. But now, can you see, I need A. I need A. A, it is my what? It is my x-intercept. So for now, I'm going to say it is between A and 2. Allow me to say, I'm going to go back to the answer name. I'm going to say x is an element from x coordinate of A and 2. I'm going to come back to the x coordinate of A. I'm going to find it. Okay, let's look at the second interval. Where is it negative and positive? So we want now where f is now negative. F now negative. And now where the graph of second derivative is now positive. So it's going to be from, can you see at the same time, they alternate at the same time from which portion? From here, okay, to here. So it's going to be between 8 divided by 3. The x coordinate here is x 8 divided by 3, point of inflection again. 8 divided by 3 as well as x of c. So another solution that is x is an element from 8 divided by 3 to x coordinate of c. Now let's find x coordinate of c and x. These are the what are the x-intercept. For the x-intercept, I let y equal to 0. So I already know the first factor is x minus 2. The second one is going to be, when I have x, again I have f of x to be equal to x cubed minus 8x squared plus 5x plus 14. Then I'm going to have x squared minus 7 and then negative 2x squared plus what should give me negative 8x squared. This should be minus 6x. Okay, and then should be equal to 0. And then x minus 2 x minus 6, x minus 7, x plus 1 is equal to 0. And then I have x is equal to 2, which you already know. X is equal to 7, and x is equal to negative 1. So x of 8 is negative 1. This is negative 1. This is 7. Then I can now complete my statement and say x of A and x of C. This is B. Okay, so I can say now it is between negative 1 and 2 and this 1 and 7. Someone might write it like this. X is going to be between negative 1 and 2. X is going to be between 8 divided by 3 as well as 7. Interesting question. For which values of t will this graph intersect f at 3 distinct points? So now, for something to intersect at 3 distinct points, by the way, guys, you need, okay, it should be here, between the turning points, because check, at the turning point, it is twice. Okay, let me redraw that. At the turning point, it is 2 times. Here at the turning point as well as there. Also at this turning point, it's going to be 2 times. Here as well as here. But now I want it to intersect 3 times. So it's going to be, okay, it needs to be between the turning points. So now, let's now try to find okay, I removed some important information here. Let us now try to see. Okay, first thing first I'm going to do, I'm going to say, okay, let me now equate h of x to f of x first. Then I'm going to let this one to be equal to h of x, by the way. And then I'm going to say this is the same as negative 11x plus t. It is equal to negative, okay, x cubed. Guys, just remember this part, that for these to have 3 distinct points, it should be the value of whatever t should be between the y coordinate of the turning point. Okay, y coordinate of the turning point. So it's going to be minus 8x squared plus 5x plus 14. And now let's do algebra. So it's going to be 0, it is equal to x cubed minus 8x squared plus 16x plus what? Plus 14 plus t. Now, let's let this to be equal to, g of x, another function g of x. Okay, so if this is my function g of x, let's say I now have my function g of x, it is equal to x cubed minus 8x squared plus 16x plus 14 plus t. For this value of t to have 3 distinct roots, it needs to be between the turning points. So first thing first, let me find the turning point of this graph. Okay, and say the value of t should be between those 2 turning points. Now, how can I find the turning point? I know the derivative of this should be equal to 0. So I'm going to have 3x squared minus 16x plus 16, it is equal to 0. Remember, these are the constants, okay? And then, let me see, 3 multiplied by 16. And then divide by 4. Okay, so I'm going to have vectors. So it's going to be negative 16. This is going to be 48. It's going to be 12 and 4. Both need to be negative. So I'm going to divide by 3, by the way, by 3. So I'm going to have 3x minus 4 as well as x minus 4 is equal to 0. Then I will have the turning point at x, it is equal to 4 divided by 3, as well as at x, it is equal to 4. But now remember, it needs to be between the y values. So I'm going to say, let me find g of 4 divided by 3. It's going to be equal to how much? Let me quickly do that on my calculator. 4 divided by 3 cubed minus 8 into x squared, which is 4 divided by 3, squared plus 16 into 4 divided by 3, 4 divided by 3, and then I don't know the value of t. Oh, it's fine. It's fine. I'll just continue with that value, and then I'll just add plus t. So it needs to be between 634 divided by 27 plus t. Okay. And what? Let me just quickly confirm something. Let me just confirm that. Just a moment, guys. Okay. Oh, now I see. Oh, my calculator. Okay. By the way, this when we transpose this was supposed to be negative. I see here. And then it means here it's supposed to be negative, even though it had no influence on the answer. And then minus t. So yeah. And then I'm gonna find g of 4. Okay. G of 4 gives me something like, let me quickly punch that on my calculator. Okay, I get 14 minus t. Now these are our, let's say we have a graph like that. We have the coordinates here, 4 divided by 3 and 14 minus t. And then we have the other one here, let's say 634 divided by 27. Okay, x it is, oh, okay. So these are our turning points, by the way. I'm going to just write the y values. The y values is going to be 634 divided by 27 minus t, and then 14 minus t. Okay, now I said the graph should be between those two values again. So where can now that happen? So can you see, we can now say, okay, it means now t, it should be a value between these two values, basically. T, it should be a value between those 16, blah, blah, blah. Okay, so it means t should be lie between these values that are here, if I may put it like that. Okay, t should be in that interval. And okay, let me see if there's a way that I can make you understand it. If now this gonna have 3 roots only and only if these two, okay, when these two have different signs, okay, if this one is positive and this one is negative on the other side, okay, so when we have that, so this one will have 3 roots. So I can say for that, for us to have 3 roots, 634 divided by 27 minus t. When I multiply with this y value, they should have opposite signs, by the way. This is what I'm trying to say. They should have what? Opposite signs. So how can they have opposite signs? Less than 0. So I can say, okay, let's solve this in an inequality way. By the way, I know t should be already between those two. So the critical values that I have, it is, let's see which one is bigger, 634 or 14. Let me see something. 14. Okay. 634 divide, this is, okay. So it's going to be 23. Let me put it here. 634 divided by 27 and 14 here. And then the gradient is going to be negative, by the way. Or positive, negative by negative. So it's going to give me something like this. So where is it less than 0 on this portion? So it tells me that t should be between 14 and 634 divided by 27. So this is how the value of t should be. It should be, or should be. Yes, it should be, basically. Okay, it was an interesting one. It was an interesting one. Okay, yeah.